Good afternoon, everybody, and welcome back to another math learning video. Today, we are going to be diving into division. And I know a lot of you have learned the methods we're going to talk about. There's one method not a lot of people know, but I really love it. It's my absolute favorite, and you'll hear me raving about it in class. I think it's so much easier than the standard ways of doing things. So we're going to talk about three strategies. One strategy of which kind of comes with a second part. And your students need to be able to understand 4-digit by 2-digit. So let's get going. All right. Our first strategy today is one that they should know. It's called the forgiving method, or also known as, so I'm just going to put a little AKA, repeated subtraction. Now this one has a fairly simple setup. The problem that we're going to be working with through all of the strategies, so you see the connection, is 3,786 divided by 29. And that is going to give us a quotient. Now, the vocabulary you need to be using. Our largest number, the number that is being divided, is our dividend. The number of groups that we're splitting our dividend into is our divisor, and our answer is the quotient. So we're going to start by writing our divisor, and then our division house is what most people call it, and our dividend is going to go inside, which is 3,786. The forgiving method works by using multiplication facts that you can think of, usually multiplying by 10 or 100, something like that, to give you general round numbers that you can break this down with. Now, I know that I can multiply 29 times 1,000, or 100 times 100. I'm getting ahead of myself. 29 times 100 is going to be 2,900. So I'm going to go ahead and subtract here. 6 minus nothing is 6. 8 minus nothing is 8. I need to regroup. 17 minus 9 is 8. 2 minus 2 is nothing. Okay, so I still have a number large enough that 29 can fit into it. Now, this number is not big enough for me to take out 2,900 more. So this time I'm going to do 29 times 10. Because I know that 29 times 10 is 290. And I'm going to subtract again. 6 minus nothing is 6. I've got to regroup. 18 minus 9 is 9. 7 minus 2 is 5. I can still take out another 290, so I'm going to do times 10 again. Subtracting 290. 6 minus nothing is 6. 9 minus 9 is 0. 5 minus 2 is 3. Still have enough to take out another 290. Six minus nothing is 6. I have to regroup. 10 minus 9 is 1. 2 minus nothing is 0. Now, I've now gotten it down to a number that is smaller than my divisor. So I now know that this is going to be my remainder. All right, so now I need to go back and I need to look at these numbers here, at these hundreds and tens. I need to add up 100 plus 10, 20, 30. So my answer is 130, remainder 16. Now, how this relates to the partial quotients. If you remember back to when we were looking at multiplication, we were talking about partial products. Well, we can kind of do the same type image with division and a partial quotient. So let me show you what that's going to look like. I am going to have a total up top of 3,786. I know I'm dividing it by 29, and it's going to be broken up somehow. Okay. I'm going to start with my 100, and I know that 29 times 100 was 2,900. So that's times 100. And then I took out 10 more, so 29 times 10 was 290. I took out 10 more. And I took out 10 more. And that left me with a remainder of 16. So this is just another visual that you can use. And then once again, you just add everything up. 100 plus 10, 20, 30. And bring down your remainder. Truthfully, partial quotients is, to me, just a way to break this down into a more simplified version. If this helps you, awesome. If not, I don't want you to freak out over it. Truthfully, I don't like forgiving method, especially once we get into decimals, because I feel like it confuses students. But if you want to work with forgiving method for whole numbers until you're comfortable with the other two methods that we're going to talk about, that's fine. But otherwise, decimals are going to become a bit of a struggle with forgiving method and that repeated subtraction. So let's look at the other two. Now the next one is my absolute favorite method ever. It's called Cookie Thief. And the reason I love Cookie Thief is that it comes with a story. And if you love it like I do, I find myself telling this story in my head. I don't really use any other division strategies because this works with every type of division. And you'll see the connection between Cookie Thief and standard algorithm here in a minute, because Cookie Thief goes horizontally while standard algorithm runs vertically. So let's just get into it. In an apartment complex, there is 3,786 cookies. The mob boss one night tells one of his thieves that he needs to go to this apartment complex and he needs to steal cookies in sets of 29. And he is to come back with as many sets as possible. So the thief goes up to the apartment complex. And in apartment A, there are cookies, and he notices that in the other apartments, there are also cookies lingering. Now, if you notice, look at the spacing. The spacing in this is going to become vital. So whoops, Ms. Pike made a mistake. I was thinking about the story and messed up my number. And this is why they created whiteout. For people like me who can't think and talk at the same time sometimes. There we go. Now our divisor is correct. So the cookie thief looks in the window of apartment A and says, "Ah, dang it. I cannot take any cookies. None." And he knows that because 3 isn't big enough to divide into 29. Well, he says, dang it, 29 times 0, not 0. It means that all 3 of those cookies get to escape next door to apartment B. So he runs around the building, finding the window until he finds the window for apartment B. And he says, yes, I can take cookies. I can take one set of cookies because I know that 29 times 1 is 29. But that still means I didn't get all of them. I don't know if the boss is going to be happy about that. So he figures out that 8 cookies escaped and ran next door. So he circles the building again, going up and down stairs, and he finally finds the window for apartment C. Says, yes, I can steal cookies again. And the cookie thief goes, wait, I'm not sure about how many cookies I can steal. And he goes, well, let me think about this. I know that one set is 29. If I add 29 more, that is 58. So 29 times 1 is 29. 29 times 2 is 58. Let me see if I can keep going here. I'm going to add another 29 cookies. Let's see if I can steal a third set. Ooh, 29 times 3 is 87. That's close. Boss is going to be happy with that one. So he says, I can steal 3 sets of cookies. And he reaches in through that window, snags 87 cookies. But one little cookie escapes and runs next door. So once again, the cookie thief starts running, circling the building, looking for that apartment window, and he finally finds it. And he heaves a big sigh. He shakes his head and says, man, the boss is not going to be happy. I can't take any cookies from this apartment because 16 is smaller than 29. So he says, I got to figure out how many cookies are escaping from me. 29 times 0 is 0. And so he finds that 16 cookies have run to the roof, the one place that he cannot get to. So that is the story of the cookie thief. I love the cookie thief. A, because this takes up a lot less space. It's a lot less confusing to me. The steps are a lot more simple. And I just love the story. So now let's see how cookie thief compares to standard algorithm. So actually we need to finish this one first. 130 remainder 16. So once again, we're dividing 3,786, our dividend, divided by a divisor of 29 to find our quotient. Now, most people recognize this setup because standard algorithm is the usual way that people are taught to do long division of any kind. Okay, so I cannot divide 29 into 3. 3 is too small. But I can divide 29 into 37. I can do that once. 29 times 1 is 29. And I need to subtract. I have to regroup. 17 minus 9 is 8. 2 minus 2 is 0. Now I need to bring down that 8. I can fit 29 into 88 3 times. We've already figured out 29 times 3 is 87. Subtract out. And then bring down that 6. I cannot divide 29 into 16. It's not possible. 29 times 0 is 0. I have nothing to bring down. And so now that 16 becomes my remainder. Now let's take a look at this. 37 minus 29. 88 minus 87. 16 minus nothing. And then 16 being our final remainder. The cookie thief method takes it horizontally, where standard algorithm takes it vertically. It's the exact same process. Cookie thief just happens to come with the story. So that is the 3 ways that we can solve standard long division of whole numbers. Students will have chances to work with these. If they need extra practice, I promise they will be getting it. We will be reviewing these strategies all year long because students have to be proficient and strong in being able to do long division with whole numbers, multiplication with whole numbers, and be able to input that with word problems. All right, well, thank you everybody for joining me. That was our first video on division for 4 digits by 2 digits for whole numbers, and we will see you next time.